I'm Shawn Rutledge. I've been a Qt user since about 2004. I've been at the Qt company in Oslo for about 5.5 years now. And I was always interested in working on touch, trying to improve the support for touch events in Qt Quick. And also kind of adopted Wacom tablets a bit because they have been neglected a bit in the past. So I work mostly on Linux and Mac OS platforms. And I've fixed bugs for low-level stuff on there too, like the Wacom support. And worked on controls a little bit, not too much. I did the Qt Quick Dialogues implementation, which was based on Controls 1. In the future, I'm interested in working on some graphical items like the path support, maybe ellipse, things like that. PDF support. Maybe I'll get to work on printing. It's a lot of these things are overlapping with what other people are doing, so we'll see what I find time for. But for now, I'm working on trying to make touch work better. So, agenda for this, we'll talk about what's wrong with existing support with the mouse area and things like that. Goals, what we're trying to fix, how we're going to try to make it better. An introduction to pointer handlers, which is a solution I kind of came up with. And demo of several of those. Comparison of differences between that and the existing mouse area and things like that. Weak and strong grabbing, what's left to work on, and maybe there might be time for questions, but I think probably this is too much for half an hour, so we'll see. Okay, so starting with what's kind of wrong. So we have at the top here flickable and then a rectangle which changes color depending on whether there's a mouse area being hovered or not. So when I put my cursor over there, it's hovered. And then inside that, then I have another rectangle, another mouse area, and it's also checking whether it's hovered. So this is the one case when you can actually have two areas being hovered at the same time. There's one of them that's inside the other. Now, I also have another rectangle with another mouse area which is not inside. And so when I go into there, it's hovered, and the outer one isn't anymore, even though right now my cursor is actually on top of all three things. Why shouldn't they all be hovered, right? So I think maybe we should fix this, but I haven't quite figured out how yet. But another thing is that actually I do have a work in progress patch for that, but I haven't worked on it for a while, so I need to get back to that. Another thing is that as soon as when you press this mouse area, it changes color to show that it's pressed. As soon as you start dragging a little bit, then the flickable outside steals the grab, and so it's not pressed anymore, even though it really is. And it's not hovered anymore either, I think. Well, maybe it is. These things are kind of a little unpredictable, or a little unintuitive at least. You have to kind of know how things work for this to make sense, right? So this is a similar kind of situation, except now we've got three different mouse areas. The top one here is totally normal, and as soon as you start dragging, the flickable steals the grab, and so the mouse area is not pressed anymore. The middle one, as soon as I press, mouse accepted as false, because it does this on pressed, mouse accepted set it to false, so that's basically rejecting the press event. And if it rejects the press, then it's never going to see any more events, because the only way that it can see updates is if it grabs, and so it has to accept the event, and we tie accepting the event to the grab. So there's no grab, so it doesn't show any feedback that it was pressed, and the flickable will still steal, will still take the grab as soon as you drag past the drag threshold. Okay, the last one, we did prevent stealing true. So in this case, I press, and I try to drag, and I can't, because so this is the one mechanism that we have to prevent the flickable from stealing the grab from this mouse area. So isn't it kind of odd that we had to change mouse area in order to keep flickable from doing something we didn't want it to do, right? I'm not sure if I've got the right way to improve this yet, but it seems like we could do better maybe. And of course, because of, well, I'll get into the event hierarchy a little bit. Well, actually the event hierarchy is up here. I have a bigger slide later on, but we have touch event, mouse event, tablet event. They're all delivered different ways in Qt Quick Window because they're independent events with no common base class except for a QInput event. So the delivery logic was kind of a mess. And I wanted to add support for tablet events, but we don't have support for that, and it would be a lot of trouble to add it because of that being a different event. It would need all different logic, even though it's rather mouse-like. So, MouseArea, right in the name, it says that it handles mouse, right? And then when they realized that they wanted to handle touch devices, then they started shoehorning the touch events into mouse events, synthesizing them, and so that MouseArea can handle those, just because MouseArea was in wide use by that point. So we would like to instead have common event delivery code QQuick window for mouse and touch, which basically means that they need to be the same event in some sense. And we'd like to have these pointer handlers I'm going to introduce. We'd like to have both QML and C++ APIs. So if you want to do some custom event handling, you don't necessarily have to start with QQuick item and handle every aspect of the events yourself. There would be some reusable code that you would inherit from and customize the behavior a little bit. And I think that the events should always have velocity, because Flickable has to calculate this for itself. So far, it's the only item that actually cares about velocity. So we never really tried to provide velocity globally. It just calculates that for itself. But I think there are cases when, like if you saw the Bluescape demo, they were dragging objects, dragging windows across the screen, and then when they stop dragging, it has a little momentum and it keeps going. So this isn't a Flickable use case, but it's another case where they would care about the velocity, right? So they probably had to calculate that themselves too. And I think that this kind of feature should be something that's built in. So those goals were for the present short term, and this is a little bit further in the future. I'd like to have support for Wacom tablets. As soon as we get that generic path support in QtQuick, then you'll probably want to be able to use a Wacom tablet to draw the paths, right? I want to refine the APIs. So these pointer handlers, which I'm going to talk about, we should try to get them to a point where they won't need to change in Qt6, at least. We'll be adding features, but not ripping things out. So we're being kind of slow about this because we want to make sure we get the API right. Wayland is a platform that has supports for multiple seats and users. And on X11, there's also been experimental support for multiple mice in the past. I'm not sure how widely used that is, but Qt doesn't support it because mainly it's because of the concept of grabbing. There can only be one mouse because there's only one grabber. So maybe we could try to support multiple mice in Qt6 if it turns out to be possible, but that's a lot of work, so it's not really a promise. It's just I'd like to work on that. And of course, I'd like to get rid of this touch-to-mouse synthesis because that's really, yeah, that was just a hack, a workaround, and here we are still depending on that. So somebody once said, you know, the keys attached property is really kind of nice because you can do these one-liners. You can just say keys on left press, do something, whatever it is. So they said, well, why don't we make the mouse and touch handling more like that? And that was actually a couple different people in the office that had the same idea independently. So that's what I started investigating. But the trouble with this is when you do this, you're actually creating an object here, the keys object, which is associated with that item. And you can only do that once. So you'll have one key handler object for that item. And you might like to actually have different behaviors done in different ways. So like, for example, there's this TapHandler. It's a handler object which handles taps. But suppose you want to handle a tap on the mouse button one way, a tap on the right button another way, and a tap on a touchscreen yet another way. You might like to have different instances of the TapHandler. So it actually works better if they're child objects that are declared, just like the MouseArea that we already have. The difference is that these pointer handlers are not items, they're just Q objects. So that makes them a little bit lighter weight, and it also implies that they're going to handle events over the area of the target item. So the target item is whatever they're declared inside of. You have a rectangle, then you declare the tap handler for that rectangle. So you don't have to do anchors fill parent because it's not an item, it doesn't have its own geometry, it's a behavioral object. It's like the control layer of your MVC. It handles events and does behavior on behalf of the parent rectangle. For drag handler and pinch handler, it's really simple. You just declare them and suddenly you can drag this rectangle or pinch this image. So easy stuff is easy. The object is lighter than an item, lighter than an attached property as well, because attached properties actually have their own overhead. And we are going towards having multiple small, lightweight handlers instead of MouseArea, which is monolithic, which has to do a lot of different things. It has to be able to drag its parent. It has to be able to handle taps. You care about double clicks, and you care about wheel events, all kinds of different things, right? And it'd be nice if we actually broke those functionalities up. And of course, the default target, whatever you declare it inside of, you use its bounds for the area in which you're getting the events. But I also have a feature in mind where you'd be able to change the target. So if you have, for example, a pinch area is the best example, because sometimes you can put a pinch area in something and then you can pinch it down so small that you can't get your fingers inside the object anymore. So you can't really zoom back out again. So maybe if you have a large area in which you know that you want the pinch gesture to be active, then you would declare the pinch handler inside there, but then you would set the target to something else. That's the object that it acts upon. So it handles events inside one area but affects another object. Okay, we would like to use declarative handlers as much as possible for gestures. So each of these, like tap is a gesture, drag is a gesture, pinch is a gesture. Each of those would have its own declarative handler. But also, those would tend to be agnostic. So like tap and drag, you don't really care whether you're using a touchscreen or a mouse. They should be, the code shouldn't have any different code paths because it's just doing the same thing with the same type of event. Pinch, of course, is only touch specific because you have to have at least 2 fingers. So there will be some handlers that work only with mouse, some with touch, or some of them you'll be able to set flags to restrict them to mouse or touch so that you can have different behavior for different devices. And then we'll have these handlers available as public API so that you can subclass them in C++ and do all of your oddball use cases that we haven't thought of. So this is completely different from the existing items, and so we don't have to worry about backwards compatibility. This gives us a chance to have a new API. So here's the example of the drag handler. I simply have this red ball image, and I declare a drag handler inside, and I can drag it around. This is a QML slide deck, by the way. The whole thing is QML. And when I touch the screen with my finger, you see this feedback. So that's how you can tell. You can see when I move the mouse cursor, and you can also see when I touch. Next, we have TapHandler. This one is configured right now to only work with left click. So if I do right click, which is actually not so easy on a trackpad, it doesn't respond to it. But then I turn that on, and now it does. Okay, so I have a TapHandler, and it handles events inside the rectangle. But I wrote a lot of JavaScript code here. So I said, depending on which checkboxes are checked here, I control which buttons I'm willing to accept. And then when the tap happens, then I pay attention to which button was pressed, and then I change the color to give different feedback. So this is how you try to get by with one tap handler. But then this is a really good example of why you'd want to have multiple tap handlers, actually, which is why attached properties are not the best, because this way you're able to do this kind of stuff. We have one tap handler that handles the left button, another for the middle button, and by the way, that also handles touch. The left button is kind of, I'm not sure if this is a really good idea, but it's common enough that tapping the touch screen acts kind of like a left mouse button, right? So you don't have to have a different one. But you can also set which device you're interested in. So you could actually restrict it to a real mouse only if that's what you want. So here we have 3 of these tap handlers and handling different buttons and giving different feedback. Pinch handler. So this one, I can pinch with 2 fingers. And there's a new feature for the pinch handler compared to PinchArea. I can also require that it has 3 fingers. So if I do 2 fingers, it ignores it. 3 fingers, it'll start pinching. So this idea I thought of because Ubuntu was using it for window management at some point, that you could use 3 fingers to change the size of a window. And I thought, well, how would I implement that? Like in a Wayland compositor, for example. I need a handler that will require 3 fingers. So I just set this required point count here. And that's what does that. And there's minimum and maximum scale and some other things like that to control behavior. Like this one will be restricted to plus or minus 45 degrees. And you can't scale it too big, and you can't go too small. Okay. The next thing is that if you try to use pinch area on a map, what you'll find out is that pinch area changes the zoom of the item. And the zoom is always relative to the center point. It could be relative to one of the other corner points. There's an enum where you can choose whether you want to zoom relative to upper left or lower right or something like that. But by default, it's in the middle, so you always zoom into Africa on a map like this. So, you know, say I want to zoom into California, I should be able to do this, right? Actually, it depends where I put my fingers, where I'm going to zoom in or out. So then I can zoom into whatever part I want. And in this example, I also did this re-rendering thing because this is an SVG that I'm rendering, so the source size has to change depending on the resolution so that I get higher quality as I zoom in, but at the cost of slower rendering, of course. So PinchHandler, and if it's not active anymore, then re-render if necessary. So this active property is basically just saying, is the handler doing what it normally does? Has it grabbed? Has it started pinching? And I try to make that uniform. So a tap handler, if it's active, that means you're in the process of tapping, and if you're with a pinch handler, it's in the process of pinching, and so forth. So conceptual changes, handlers versus areas. Either a handler or an item can be the grabber, because so far only an item could be the grabber, right? But the handler is just a Q object, it's not an item, so we had to kind of broaden the scope a little bit there. That if a handler explicitly grabs, which it does have to do, then it will become the grabber itself. And it also knows what its parent or what its target item is. That's another property. We have this new rule that if the number of touch points changes, we're going to ignore the grab and start over with the event delivery. So this is for handling the case when you have both a tap handler and a pinch area, for example, or something like that. Or let's say a tap handler and a drag handler at the same time on the same object. Then when you tap and then you start dragging, the tap handler would have to actually give up the grab so that you can start dragging, right? So they have to kind of cooperate with each other. So when the tap handler sees that you've gone past the drag threshold with your finger, then it should actually give up the grab so that the drag handler can take over and start dragging. So that's one thing, is that it can explicitly grab and ungrab. But there's also, if the number of touch points changes, like with the pinch area case, if you have both a pinch area and a drag handler, then when you start dragging with one finger, that's one thing. If you start dragging with two fingers, then the original drag handler is not satisfied anymore because it sees that there are two fingers and that's not relevant to it. So it should actually give up the grab so that the pinch handler can take over. So handlers in general should give up the grab when their constraints aren't satisfied. And because of the trouble with the event hierarchy, I mean, the touch event had multiple points inside. I actually call it a cluster bomb. It's like a single event with multiple points inside, right? So in order to make our interface more uniform for delivery purposes, we're going to have to model all the events that way. This was Lars's idea, to also do this with the mouse event so that it has one point inside. So the pointer handler receives the complete event during delivery. This also helps with that case with if you have something that's pinchable but you've pinched it down too small and you can't get both your fingers inside, the pinch handler could actually look at points that are nearby as well and decide to act on those. Whereas with the existing event delivery in QQuick window, we were actually customizing the events to include only the points that are inside the item because we thought that's the only thing that's relevant. But we shouldn't be so restrictive. Right, and explicit grabs and ungrabs we already talked about. So to handle this, the ability for different handlers to pay attention to different scenarios, they basically need to be able to monitor events more often. We want to let the events propagate, and the exclusive grab should actually be less common over time, because when you grab, it's always exclusive and you're excluding any other items or any other handlers from seeing the same events. So I kind of came up with this idea that maybe we should have a weak grab, where basically accepting an event is a different thing from grabbing. If you accept the event, that means you're interested in receiving updates, but it doesn't necessarily mean that you prevent anybody else from receiving updates. So there's a flag in the pointer handler which gets set saying that it has previously been interested. And then during delivery, as long as nobody has grabbed yet, we keep delivering to all of those handlers that had expressed interest. So the way that they expressed interest, there's this virtual bool once event point. So there's also a virtual once pointer event, which takes the entire event, and then it goes through the points, and it calls once events point to ask the handler if it's interested in that point or not. So if any of those return true, then this also returns true, and then this handle pointer event impl will be called. That's another virtual that you can override in your handler. And then all of the existing handlers already do override it, so they're implementing their behavior that way. We're thinking about, for the sake of QML, maybe we should have these signals like press with an event point, update with an event point, release with an event point, and then if you were to take the event point and set accepted to false, then that would mean that once event point will return false, and if that happens, then we should probably also ungrab if it was already grabbed implicitly. But there's also going to be explicit invocables for grabbing and ungrabbing. Okay, the event hierarchy, I finally got to it. I mentioned before that there's this input event base class, and then we have the touch event that has multiple points inside. But here's a position, here's a position, here's a position, here's a position. There's no base class that has those, right? So this is why our event delivery is such a mess in QQuick window, because there's no base class that ties these together that looks like a pointer event. We have key event also inheriting from input event, but those are handled differently, so we can't really unify that. So since we would have trouble actually changing this before QtQuick, because what I would like to do is put in here an intermediate class called QPointerEvent, but we can't do that till Qt6, so that made it really hard to prototype, and we want to at least hash out what the UI should look like in QtQuick ahead of time. So what we did instead is we came up with this wrapper object, QQuickPointerEvent. And there actually already were wrappers like that. There's a QQuick mouse event, which if you're using a mouse area and it has this signal, there's a signal that actually emits the event, and then you can set accepted to false. That mouse object that you're getting is actually a QQuick mouse event. It's a wrapper, and it used to be before, I think 5.7 or so, that we were instantiating that every time. Every time we deliver a mouse event to a mouse area, we would create one of these QQuick mouse events just for the purpose of exposing the API to your QML. And there's one of the guys in Berlin, Eric Verbruggen, he came up with an optimization where instead of creating the new object every time, he would just reuse the existing object and keep it around and call a reset function to give it the new pointer event. And so we did the same thing with this. There's QQuick pointer event, which will take whatever kind of Q event and wrap it so that it can have a common API inside QtQuick. And these objects are not, they're never destroyed. They're created and then kept around and used for delivery. So this is in 5.8, this is already what we're using for event delivery in QQuick window. We deliver the QQuick pointer events, and then whenever we get to a place where we actually need the original QMouse event, because we're delivering to the legacy virtuals in QQuick item, then we just pull it back out again because it's just a wrapper. But the handlers are actually working with pointer events, so they get to use the new API. A pointer event has a device, so this gives you all the information about where it came from in case you want to discriminate on that basis. If you want to say, did it come from a tablet? Otherwise, I'm going to ignore it, or something like that. And you can find out what the capabilities and maximum touch points and all that kind of stuff. Then as a subclass, we have QQuick pointer mouse event, because that one only has one mouse point inside. We know that it's only one, whereas the touch event, it has multiple points. The point itself is consistent for between mouse and touch, but then we have this subclass touch point, which adds only touch-specific things like rotation and pressure. I've also been trying to think about supporting TUIO, 2EO a bit better, because there's some touch devices that use that. So they actually provide rotation and pressure and a unique ID. So that's in the touch point. So when you get a QQuick pointer touch event, it will have touch points inside. And our handler hierarchy so far, we've got the pointer handler base class, which is purely abstract. And it has a target, which is the item that it was declared inside of by default. And every item private has this extra data possibility. It's like it's kind of a private, which is for stuff that we don't use very often. So most items don't have the extra data instantiated, but some of them do. And so I put this pointer handler's vector in there because we don't want to have the overhead of storing a Q vector of possible pointer handlers in every item, when actually most items are not going to have handlers. So it's in the extra data, so that'll get instantiated if there's a handler. And then we have a device handler. This is the one that's able to discriminate based on the device. You can say accepted devices, accepted pointer types, accepted buttons, and accepted modifiers. And then that handler will not be active if any of those constraints are not satisfied. It'll just ignore the event or reject it so that it can go further. Then we have a single handler, which is the base class. It's also abstract. It's the base class for handlers which only care about one point at a time. So like tap and drag, those only require one point and don't really know what to do with anything else. And then we have the multi-pointer handler, which is for handlers that care about a certain number of points. So we have this required point count. And that's, for example, the pinch handler. If I say that I want to have 3 points, then it's going to ignore the events until there actually are 3 points. And then it will grab. And I'll say, OK, the pinch started. So there could be further subclasses of this if we come up with any more handlers that work that way, that handle multiple points. So the delivery, it starts with QQuick window. It gets the original event. It creates a QQuick pointer event as a wrapper, and then it starts going through the item hierarchy and delivering those just like delivery always worked, except now they're the pointer events instead. So what I have left to work on. We haven't replaced the Flickable yet, but we probably should. We should write one that uses pointer events, because Flickable only handles mouse events so far, so it depends very strongly on that synthesis, which means if you have anything that handles touch inside there, then it has to, it can only steal one grab, which corresponds to one touch point, which is currently acting as the synthesized mouse. So we need to have a Flick handler that actually handles touch and mouse agnostically, just like the other ones will. Need to do something still with scroll and wheel events. We haven't put those into the pointer events yet, but I think we probably do. Same thing with native gestures. That's like on a macOS trackpad. We are not allowed to actually see the individual touch points on the trackpad. We get gestures from the OS where it's telling us that there's a pinch happening and it's at a particular position and here's the distance and so forth. Or the flick, it tells you how many pixels you should move your content on the screen in response to that flick. So those gestures have to be, they're separate events. They have to be propagated separately so far, but we'd like to put those into the pointer events as well. This whole weak grab concept, I'm not completely sure if it solves all of the problems. And I think we just need to prototype a lot of different UI concepts and make sure that it actually does cover all the cases. And I actually think that this cooperation between handlers is a little bit, it's a bit like cooperative multitasking. That's what it reminds me of. I mean, preemptive multitasking was invented because cooperative multitasking wasn't powerful enough. It was possible for one application to hog the entire system. If anybody remembers back to really old versions of macOS, that used to be a problem. So I think maybe we will actually have to solve the problem where you monitor without grabbing, but then you can grab preemptively at any time, regardless who else has the grab. We need to, on the one hand, an arms race is kind of a bad thing, and grabbing is an arms race. But on the other hand, if we don't fully enable the arms race, then I don't know. It seems like we don't have all the cases covered. So we still need to work on fleshing that out. And of course, we have to get ready for having a public C++ API. So there need to be private implementation classes and so forth. And yeah, how to manipulate hidden handlers, which are inside components. Maybe we still need to add the attached properties. And then there's been a lot of research about reactive programming. So if anybody has any ideas about that, how that might apply to QtQuick, or if there's any ideas we should be reusing, I'd like to hear about that. Or if there are any UIs that you can't implement with this stuff. So that's it. And do I have time for questions? No? OK.
Am I on? Oh, there we go. Okay, thanks
Yep.
very much, Shawn.
Thanks.
That was really interesting. I think I